the Oshkosh truck Hemet front axle, the front axle, as you can see over here. You got the whole thing in focus, or you got the whole thing?
Yeah, I've got the whole thing. Just look at it right now. It just doesn't look good to me. When you gave it to me, it just looks even different.
It's in focus.
Okay.
It's in focus.
Okay.
Let me just see the focus mechanism function. Yep, it's functioning. Okay. All right. This is your input yoke, which is coming from the transfer case, the front of the transfer case. Okay. It is a steering axle, so you can see here the tie rods would actually be functioning. Okay. And it's totally independent of the rotation. You can have the rotation going on while the steering mechanism is rotating. And as I'm demonstrating here. Okay. You've got one axle. You've got one wheel with the brake disconnected, the brake chamber disconnected. And the reason for that was so that you can actually expand the brakes and you can see that yourself. I'll demonstrate that in a few minutes. Here's the whole thing. And again, we've got casters and all the available hardware, and they've got grease fittings on them, and they swivel and everything for the device. Okay. And we've got a pointer, a laser pointer. I wonder if you can see that. Let's just do that for the hell of it, see if it works on the video. Can you see it? Good.
Yeah, okay.
It's on the yoke right now?
Yeah.
Oh, let's see if I can get it to work instead of using the stick. So here is the nameplate, okay? You can see over here it says Oshkosh, and it's actually an Eaton axle, modified by Oshkosh for the wheel ends from that point out, from this point out. Originally it was an Eaton axle, and you can see the word Eaton on the differential at some point. We'll show it to you. Over here you've got one of the brake actuators. The chamber itself has been cut. Come over here. Get over his shoulder. Right there, you can see the chamber has been cut away as opposed to this chamber here, which is full. Okay? And this chamber has been cut away. You can see from the top. Come this way, Kush. Come this way. You can see the diaphragm, which ordinarily this threaded portion here is where the hose for the air would come in, and it would expand the chamber here, pushing down the spring and releasing the brakes. The brakes are actually released by the air pressure as opposed to actuated by the air pressure. Okay, now if we step back, guys. Okay. Here's your, if you come around over here, let's go over here first, I guess. From here, from this shot here, okay, you can see the S-cam, which is rotated by this arm right here, which would rotate the S-cam and which would expand the brakes into the drum. Okay, you can see some of the return springs here. And coming back around, you'll see here the bearings, right there, the wheel bearings. Okay, and you can see over here the seal and the outside casing, which has basically been sliced for you to see the whole thing. Okay, basically the input shaft rotates this coupler device over here. The splines on the input shaft rotate this device, which has the drum on it, and the wheel bolts to these two bolts that are left over right here. Okay, let's go around this way. You can see over here, from this angle, again, you could clearly see now the diaphragm and the threads right there, which is where the air hose would actually be actuated from. Here's some grease fittings here. Basically, this is where the swivel bearings are for the rotation. Let me see if I can pull on this tie rod. If I pull on the tie rod, you stay there. You'll see that those bearings are the ones that make it possible for the device to rotate back and forth. Now, this is the CV joint, the constant velocity joint right here. So as the device is rotating, the CV joint is making it possible for the mechanism to keep spinning and keep being driven as it's turning. Just like so. Okay. Let's come back around over here. You can see the, over here, push. You might want to back up a little bit. There's a differential carrier, the ring-in gear, I guess they call it. A couple bearings on each side. Let's wait for that carrier to come around. You can see the spider gear setup with the slice that's been removed. You can see the spider gears are actually functioning right now because the side to the right of the screen is actually not spinning, but the side to the left is. Now, theoretically, you can actually get these things to spin together. This is a normal differential with no lockup or anything. So the wheels would actually continue spinning. One wheel would actually get power at any one time. If you're going around a turn and you had a difference between the one wheel and the other wheel as far as the travel distance, it's compensated for by the gears. As you can see, they're compensating for it. If you were to continue now and actually initiate the speed for it and keep the same speed on a straightaway, then you wouldn't have a disparity. Keep in mind that you can lock one wheel, but you can't lock the other. What we'll do is we will hold this wheel stiff right here, and then we're going to try and get Joe, while shining the light, to try and hold the other wheel still, and we'll see who's going to win as far as holding the wheel still. I'm holding my wheel still, and he can't seem to hold his still. If I let mine go, he can hold his still. Okay? He's holding his still, so mine must spin. If I hold mine still, his must spin. It comes down to who has more strength at any one time, and that's actually what's happening. Now he's holding his still, and I can't hold mine still. Okay, so one wheel always gets the power, and the difference is taking place. Come back over here with the light. The adjustment is taking place right in this mechanism here. If the two are spinning together, like on a straightaway, you actually have no rotations of those internal gears. If you make a turn, then you have this situation happening, where the different radiuses of the turn and circumferences of the turn are being adjusted for by that spider gear mechanism. Okay. Now, why don't you stay right there? Okay, I'm going to come around. I want you to concentrate on this portion here, which is the...
I should move there then.
No, stay right there. Yeah, I'm sorry, move to here. Push. Okay, Joe, I want you to come over his left shoulder and hold this side still so that I can demonstrate the braking mechanism. Okay, as you can see here, you've got the brakes being the brake drum here, and then the brake pads here. And this is the side that has had the, the brake pot disconnected. So I'm actually simulating the expansion of the brake shoes into the brake drum to simulate the braking. Okay? Another thing to point out here is you've got the knuckle here. Okay? The knuckle here, you'd have the tie rod device, push-pull device, which is coming from the steering system, and it is connected to the tie rods, which are connected to each other. So one shaft actually coming out of the steering mechanism can control both wheels. All right, so again, let's hold that wheel still. So Joe right now is holding the wheel that's not visible in the screen still, and you can see that the drum is rotating around the brakes. Now if I were to knock the brakes over here and lock this side, you'll see that Joe cannot hold his side. Why don't you go back and show what's going on now? Shine it on yourself, Joe. Shine right on that shaft there, okay? On the cutaway of the CV joints. Okay? That side is spinning now, and I'm holding the brake steady. Now, come back over here. I will release the brake, and while Joe is holding his side steady, and we'll load the driving forces transferred to this side. And again, for some reason, if my side gets too much traction and locks up, the other side will go. Okay. All right. And that's pretty much everything. Once you, oh, one other thing. Once you come around here, Kush. Come around here. I want to show the Hobbs meter. We've got a Hobbs meter around this point here, which basically keeps track of all the time that this device has been spinning. And there's a maintenance manual. And basically what you have to do is you have to make sure that within the specified intervals, you grease the several nipples that have been installed to keep this device spinning. Here's one grease nipple. I think that one might have been a new one, while that one was actually an original in the mechanism. But this one was installed because of the cutaway system. There's no longer a wet lube system. I believe there might be a couple more nipples internally. Okay. All right, just get a shot of the whole thing all around.
Do you want to show the rotation of the CV joint?
Didn't we get that?
I don't think so.
I think we did. Let's go around and show it again. Go around.
A full rotation, especially so that,
The what?
like a full revolution. So therefore you see that,
That's the CV joint.
right. So therefore you see that at the turns, it is more susceptible.
Okay. All right, here's the CV joint. And we point it out with our red dot. There's the CV joint. Now, the greatest amount of stress on the CV joint is placed when we are actually turning, like so. You see all these, this is right now hard right turning. I'm sorry, hard turning to the left. And you can see how all these devices are kinked together and they adjust to keep the rotation going. All the angles change and it's a three-dimensional type joint. Okay, now when you rotate this thing back to a, let's say, a hard right turn, it adjusts and compensates and keeps itself going. Okay. That's the whole thing. So take a look at it, take a shot all around. Get a shot of it. Hopefully around. So all these have now a laser, the four wheels, and hardware.
Mm-hmm.
And the grease fittings are basically what they do is whenever there's a shaft which is rotating, they actually the guys in the back, they basically reduce the diameter of the shaft and create a channel so that grease can actually work its way into the device and grease it, as opposed to just putting a grease fitting and hoping that it rotates around the whole thing. They create a channel, a diagonal channel that's been milled into the surface that's getting all the friction. All right, shut it down.